In today's video, we're going to cover how to make two basic versions of an outline shader, one that works extremely well for pixel art like this one here. They're customizable with color as well as thickness. And the second version that will work well with more HD or high definition artwork that has soft edges and semi-transparent pixels. All right, so to get started with this shader, I've got this pixel art style sprite here, this skeleton, and just for transparency's sake, I have scaled him 4 times to make sure that he's easy to see when I run the project. And I don't really have anything else set on him except that his texture is set to the nearest filter. If we were to reset this to initial and our game wasn't set up, then he might be kind of blurry looking like that, which means that he's using like linear kind of filtering on the texture. So if it's pixel art, we want to go with nearest. And we're going to start with this pixel art sprite, and then we'll move on to something else that's got a filter on it. But also for fun, this skeleton does have an animation on him. So you can see here, he's got like a death animation that we're going to be able to see this effect with when we put it on him. Now, in order to create a shader and add it to this skeleton, he needs to have a new material. We'll go ahead and select our skeleton. And then down here in the canvas item, we've got a material. Now, of course, we are working specifically with 2D nodes in this, right? So a sprite 2D or something of similar canvas related thing. So this shader won't work with your 3D objects. But let's go ahead and create a new shader material. So when you click on that material, there's a new shader material option. And you can go ahead and save this if you want to reuse it. So I'm going to go ahead and kind of click down here and say save as. And we've got this outline shader folder, and I'll go ahead and save that there. Okay, so there's our new shader material that we've created. And likewise, this shader material needs a new shader script. So we'll just go ahead and underneath shader and click new shader, and we can call that outline shader. And there we go. And now when you click on this outline shader, it will open it up in this little shader editor, which is just a little code editor for our shader. Okay. And it's kind of already set up with a few things. We've got vertex, which is called for every vertex material that the material is visible on. And we've got fragment, which is called for every pixel that the material is visible on. And what we're going to be using is the fragment, since this is a 2D shader. So I'm going to go ahead and just remove this vertex function here. And we don't need this light either, because we are also not dealing with lights, right? Which would call for every pixel that's being lit. Okay. But, if you were going more advanced and you need some of those, then maybe you want to keep those in there. But there we go. We've got our basic shader set up. Okay, so one thing you would have noticed is that there's a shader type here of canvas item. And obviously when we're working with 2D in Godot, we're working with canvas items. And so that's the shader type we need for this. All 2D shaders will use a canvas item shader type. And in our shaders, this code is going to be different than our GD script. It's going to have some different syntax requirements and some different ways of writing things. And so as we get started here, we do want to set up some variables that we can use in our shader. So with this outline effect that we're going to be creating, we want the user, or you, the developer, to be able to select the color for the outline. And we'll also provide just an outline thickness. It's not going to be super useful in this pixel art example, but when we look at a more HD kind of sprite, it'll be a little bit more useful. And so let's set up the variables that we'll use to control those values. And first we're going to want what we call a uniform vector 4. So our colors are going to be vector 4s because they've got 4 components, right? They've got R, G, B, and A, red, green, blue, and alpha channels. Okay, so all of our colors are going to be vector 4s, and we'll call this our outline color. This is the color that we will obviously use to color the outline, right? Pretty self-explanatory. And then when we're creating a variable that we want to be exported in the inspector, then we also want to set kind of what kind of value and how it should be displayed. And so what we can use here is there's an option called source color, okay? And we need to set this to an initial value as well. And so I'm going to say vec4, right? Because it's a vector 4. And then let's just go ahead and make it red. So that's going to be 1.0, 0.0. And finally, the alpha will set to 1.0. Okay, so that's our default color that we'll use. And then we wanted to add one other variable that we're going to use to control the outline thickness. And this will be a simple float. uniform float, outline thickness. And because we also want this to be visible in the inspector, we're going to say hint underscore range. There we go, hint range. And we can tell it what we want the range to be. So I think the smallest that we want this outline to be is maybe 0.5. And technically for pixel art, actually, you might even want to make it 1.0. So maybe I'll do that because that's going to be equate to 1 pixel over texture. And then the maximum can be 5.0. And by default, I want to set that to 1.0. And one thing I've forgotten to do because I'm used to GDScript is we do need a semicolon after each line of code in our shader file. Okay, so those of you who are familiar with other languages, this is pretty familiar. But for those of you who are not and you're starting with GDScript, this is going to throw you through a loop. You'll notice that if I remove this semicolon on this first line, then my second line is going to be invalid because you can see that the error is it was expecting a semicolon somewhere. So we'll just put that back in there. So that's a pretty important thing to have. Now I'm going to go ahead and just save this shader. And when we look at our skeleton, you can see under shader parameters now we've got an outline color and an outline thickness. And we can adjust these as we see fit, right? I mean, I could pick a color like this pink to match my color and my theme right now. And that's how those little variables work. Okay, so now in order to make this shader work, all of the code that we put in the fragment is what runs, right, as is stated here, for every pixel that the material is visible on, and that obviously happens every frame. Okay, so we're going to write our main shader in here, but we can also write functions outside of the fragment that we can call within the fragment code that will help us do certain things. So one of those examples is I want to have a float that we can easily calculate. So we're going to call this function is positive. And as that name describes, what we want to do is we're going to pass in a value. Okay, so in here, this is a float value. And you'll notice this syntax is different than GDScript. I mean, if this was GDScript, you might have like a value colon float, right? Or something like that. But here with the scripting language that we're using, it's float and then value, which is the name of that variable. Now, I suppose it should be stated that the Godot's shader language it's I believe custom, but it's a shading language based on the GLSL or OpenGL shading language standard. Okay, so if you want to do some research on that, that's where you can go look. GLSL is the keyword there. Well, let's go ahead and finish this is positive function that we were creating. This function will have open with curly braces, just like that, and it'll end with a curly brace. And of course, we're expecting to return something because we started with float. That means, you know, in Godot, if we had written it like a function, func is positive, and then said float, right? Then we would know we're supposed to return a float. But obviously it's different syntax. So here we're saying we need a float. The function is called is positive. So this needs to return, and we're going to go ahead and just return. It's going to be one line of code, and we're just going to return the max, okay, which is going to give us the max number of the values that we pass in, and it's going to be 0.0 or the sign of the value, just like that. And there we go. This will make sense a little bit when we hook it up, but essentially we'll pass in a value, and if the value is 0, then it'll return 0, but the sign of the value will return will help convert that number to just 1 if it's 1, okay? And so that means, like with this pixel art, we don't really have transparent values. And I know you're kind of wondering, well, what if I do? And in the next example we'll do in this video, you'll see how we can kind of alleviate that a little bit. But there we go. So we're just going to check to see if the value is positive or not with this little function. Another way we could look at this, maybe we could call this is transparent. I think actually that's a more suiting name. And then we're also going to need a function in here that helps us check and sample the neighboring pixels to see if it's a solid pixel or not. And so what we'll do is in this function, we're going to utilize this is transparent. And in fact, I keep changing names. Let's go ahead and just change this one more time. And we'll just say is solid. Perfect. I like that even better. Okay, so there's our is solid function. And I'm going to go ahead and expand this code window so we can see a little bit more. So let's make our next function, which is also going to return a float. And the function name here is going to be called has solid neighbor. Neighbor, okay? But this is going to require us to pass in a few things, because what we do is when we go through the shader, if we're checking a pixel, what we want to determine is, like if we're looking at this skeleton, right? Let's say we're looking at this pixel right here. We want to see if it has a solid neighbor, because if it does, if it's got a solid neighbor left or down, then we know that this is going to be part of our outline. But if we were to look at like a pixel out here and check all around it, there are no solid neighbors, so it's not going to be part of the outline. So I hope that makes sense a little bit what we're doing here. So this has solid neighbor function is going to be used to help us determine that. And the is solid function is going to be used on a per pixel basis to just sample that and see if it's solid or not. Okay. And it'll do that based off of this value that we pass in, which is going to end up being the alpha value, the alpha channel kind of value that we read. Okay, so in this has solid neighbor, we need to be able to sample the texture as well as the UV coordinates, which is the coordinate space to tell where that pixel is. And we also have something for pixel size that's often used here. I'm going to go ahead and omit the pixel size, and we'll just go with the first two values. So first we have our sampler 2D. And you can see this is already popping up as I type it. And this is going to be our texture sampler, which will sample the texture. And then we also need a vector 2 value. Okay, so a 2D coordinate, which is going to be our UV coordinate. Okay, just like that. So we're going to have to pass those in. We're going to need those. So then what we can do is we can check the pixel based off these values. And because we also have a variable in here that's outline thickness, we also need to be able to check maybe our outline goes, 2 pixels out. And so we need to know how far should we sample. Okay, so what we will do here is first, we'll just say the offset that we're checking is a vector 2 is going to equal the outline thickness and then multiply that by the pixel size, which actually is going to be 1. So I'm just going to say that it's the outline thickness. But the catch is that the outline thickness is just a float. It's not a vector 2. So what we can do is multiply this by, we can just assume that we have a 1 pixel size sample that we always need to make, since I'm building this one for pixel art. So we'll just make a new vector 2 of 1.0, 1.0, just like that. So there's our offset. Now we've got our thickness and it goes in 2 directions. And then next, what we need to do is we need to find the alpha in each of those directions, the alpha of the neighbors. Okay. Because essentially, if the alpha is solid, then we know that it's got a solid neighbor, and if it's not, then it does not. Okay, so what we can do is let's just make a float, and we'll call it the sum of the alpha, because it's not super important which direction the neighbor is. That's transparent here, because we're just literally checking each pixel. It's only important that a neighbor is solid or not. So that's why we're going to just sum the alpha, and we can check. So we can say, we can grab our texture, which is a function you'll always have access to within these shaders. So we'll say texture, and you can see that the texture requires a sampler 2D and some coordinates. So we'll just pass in the coordinates that we want. So we'll start by passing in our texture sampler, or sample, I guess it is. Okay, so there's our texture sample. And then we also need to provide a coordinate. And what we're going to do is, since we're going to check each pixel, we're just going to do it in left and right and up and down. So we just are going to check this 4 times essentially. So we'll go ahead and we'll just say, we'll get our UV coordinate, which is going to be the coordinate of the current pixel that we're on. And then we're just going to add a direction to this. And this offset is going to be used to tell us how far to check. Okay. So we'll just say that the texture sample, or that the coordinate that we want is the UV coordinate plus, and then we'll say vector 2. So we need a direction, and we can do this. We'll start by going 1 on the X and 0 on the Y, which will check the pixel to the right. And then we will multiply this by our offset. Okay. Now, of course, this is giving us an error, partly because it's saying we can't assign a vector 2 as a float. We're checking this piece of the texture, but all we really want from that is the alpha value. So we can say .a. So we'll grab the texture and we'll sample it at this spot and check its alpha. And because we're doing a sum, we're going to add, and I'm going to go ahead and go down to the next line, and we'll copy this here, and we're just going to repeat this for the other 3 directions that we haven't yet checked. Okay, so we started on 1 on the X, let's go to -1 on the X. And then we'll change this X coordinate to 0, and we'll do 1 on the Y. Let me copy that. And I'm going to remove the plus on this last one, this fourth one, and I'll change this to negative, okay? So that checks a pixel above and a pixel below. So there's our sum alpha. We still aren't returning this float, so we still have an error in our code, but that's okay because now that we've summed up all the alpha channels, we'll know. Essentially what this will tell us is if any of these have an alpha, then this number is going to be greater than 0. And if the alpha is 0, then it's going to be, then the sum alpha will be 0, right? So then just to be safe, we can say return. We're going to use this is solid, and we'll pass in the sum alpha, just like that. And the reason we're using this here again is because even if it's like semi-transparent or if it's not sure, it's going to just return a 0 or 1, no matter what this sum alpha ends up being, okay? So hopefully that little bit of code made some sense. And a lot of you are just following along and copying it, and that's okay for your first time. So go ahead and do that. Okay, so there we go. Those are our two helper functions that we're going to use. Now that we've got that in place, it's time to write our fragment code, which is going to be quite simple. So let's come down here inside of our fragment, and we'll do a check. We'll say if. We're going to make a little if statement, okay? And what we want to do first, let me just make a comment here. I want to skip processing if the pixel is already opaque, right? I mean, like, for example, if we're sampling a pixel on the skeleton and trying to determine if it should be an outline, it never should be if there's already a pixel there, right? So simply what we can do is, so we'll say skip processing if already solid, okay? And so what we can do is we'll say if, and this will also help us prevent checking pixels that maybe we already drew an outline on, which I don't think could happen, but anyways. So if here, we'll just say color.a, the alpha is equal to 0. Okay, that means it's transparent. And we're only going to draw if it's transparent. Okay, so obviously all these pixels, the alpha is going to be 1, and all the blank ones are going to be 0. So it will try this code on the blank ones, and it will not on the solid ones, okay? So then once we're in here, we want to call this has solid neighbor to see if it has a solid neighbor or not, okay? And we'll go ahead and declare that as a variable so that it's a little bit easier to break down our code. So we'll call this a float, and we'll just say outline mask, because this is the mask, this is the area where we're making the outline. And then we'll just set this equal to has solid neighbor. And then we need to pass in our texture as the texture sample. And then we need to pass in our UV coordinates. Okay, and the texture and the UV respond to the pixel that it's sampling with this fragment at the time that the code runs. Okay, so that'll check that. And then all we really need to do is we just say if outline mask is greater than 0.0, then we know that we need to draw here, right? Because it has a solid neighbor. And otherwise we do nothing. And so in here we'll say color. This color is setting the color of this pixel. And we'll just set it to our outline color. And then put a semicolon, and voila, something's happening, except we got a little bit of an error, didn't we? Let's go ahead and save this, and might need to figure out what I did wrong with the code to see why I did this. So, okay, this issue is something to do with our code in here, and you know what? I tried to do something fancy and just say that this is our pixel size, but that's not going to work. That's really not going to work. And this is kind of exposing my noobness, I guess, in the matter. But let's go ahead and say that we need a pixel size here that we're going to pass in. Because clearly I did something wrong there. And let's go ahead and declare that variable as one that we pass into this has solid neighbor. And so we'll call this, just like we call it there, it'll be a vector2. And we'll call it pixel size. Boink. Okay, that works. Now down here we need to pass in, and our texture does have a pixel size. Okay, so we can just pass that in. There you go. Magically, it's working. But clearly, the pixel size is not 1, like I thought it was. And I did a quick Google search, actually, to satiate my curious mind. So the pixel size is actually the size of the pixel in relation to the entire UV map of the texture. So that pixel size is going to depend on the size of your texture itself, okay? So that is actually pretty important that we pass that in this way. But you can see now that we've done that we've got a nice little outline, and we can change the color and it responds, and we can change the thickness, and you can see how that's working. Actually, you can see it doesn't work too well with this pixel art when we get really large, because it's essentially just drawing this the shape in 4 directions. One thing you could do is you could add additional directions to check here, and that would increase that. Okay, so that's an option. If you want to do 8 directions and do the diagonals, then you can implement that, and that's going to give you more. It's going to give you essentially 8 little directions that it draws out, and it'll give you a better border for something like this. But obviously at smaller amounts, 1 or 2, then this works really, really well. Okay, and of course this one works perfectly for this pixel art sprite. But let's go ahead and minimize this a little bit, and let's bring in a more regular looking sprite sheet. I know, it's like a dad joke. And let's go ahead and apply this same, we've got this outline shader that we've created. Let's see, let's select our sprite. Let's go down to material, and let's plop in this outline shader material. Boink. And how it works on this sprite sheet is not so nice, right? So let's talk about that, and then we can implement an alternate version for this. So again, we've got our thickness, and you can see that these are referencing the same material. So as I change the values, it's affecting both. Okay. And in fact, if we don't want that to happen, then we can just come up here to this material and say make unique. And now when we adjust shader parameters, it will affect only the sprite. Okay. I mean, it works okay, except that it's pixelated and hard. And, you know, if let's just turn the alpha of this all the way down. If we look at this, this doesn't really have super hard edges. I mean, I'm zooming in and it's kind of fuzzy because I'm zooming in, but it doesn't have those harsh pixel edges. And if we look at the texture settings for this, the filter is inheriting, which is the same as this linear. If I were to turn it to nearest, then we get harder edges, but even that's not going to look right because, you know, this sprite sheet is just simply not drawn with harsh pixel perfect edges like that. Okay. So we'll go ahead and address that by creating a different type of shader. Okay. So on this guy here, let's go ahead and clear our material, and let's create a new material specifically for this. We'll call it an HD outline. Okay. So I'll say new canvas item material. Nope, I don't want that. I want a new shader material. And then our shader material, let's go ahead and say new shader. Okay. And yeah, we'll call this outline underscore HD underscore shader, just like that. Okay. Now, if we open that shader up and look at it here, we've got that same base, and we can go ahead and remove these same little items. We only need the fragment. For this version of the shader, this more HD one, we're going to include a few different variables here. We do have an outline color again, an outline thickness, which I'm going to go subpixels to minimum of 0.5 pixel. And we also have an alpha threshold, because now that we're going to consider semi-transparent pixels, we want a value in there to kind of help us determine where's the cutoff for this outline. Where does the outline begin? Okay. And then likewise, and I'm going to go ahead and paste this in here, we do need a has solid neighbor function. Okay, it's going to require the same arguments with a texture sampler, UV coordinates, and a pixel size. But you'll notice here we're doing 8 directional testing. Okay, so here's the initial 4 like we did on the previous shader. And then we're going to move on to do the diagonal directions by doing, you know, a full value in each of the directions here. Okay. And what this is going to allow us to do is to have a higher precision, a more accurate outline. So it'll check all around in different directions. And then we're using this smooth step as well, so that we can transition this, even if it's a semi-transparent pixel, right? We're going to maybe draw some of our outline. Okay. So this smooth step is different. We're no longer doing that check to see if the neighbor is solid. We're simply returning the value of the neighbor. Okay, so let's go ahead and move on to our fragment code. And the fragment code for this version of the shader that I've come up with is also quite simple. We'll start by creating that outline mask variable just like we did before. Okay, so this is a float, and this will be equal to the result of our has solid neighbor function. And of course, we have to pass in our texture as well as the UV and the texture pixel size. Okay. Put a semicolon after that line. Now here, we're not going to do a check to see if the pixel or the color of the current pixel has alpha or not. We don't really care so much there. Instead, what we're going to do is we want to kind of check how to blend this. So let's make another float, and we'll call this the alpha blend factor. And we'll set this equal to, we're going to use this smooth step function where we can pass in some floats. Okay, so we want to start with like a minimum of 0, and then we want to hit our alpha threshold that we're passing in, and then what we're checking or stepping is the actual colors alpha. Okay, now once we've calculated this alpha blend factor, that's going to just kind of help us determine what to do in this next step. We need to calculate the final color of the pixel, and we're going to do that in I guess 2 lines of code, right? So first we're going to look at the actual RGB value of the color, and we're just going to set this equal to a mix. And what this mix function does is allow us to take 2 different colors and mix them depending on a third variable, right? And so the first color that we're going to pass in is our outline color. And we just want the RGB component of that, right? Not the alpha. And then the second color we'll use is the actual pixels color. And again, we'll just pass in only the RGB components. And then we'll use this alpha blend factor to calculate the blending, okay? And what this will do is it's going to say, and I don't know, it's not really showing up yet because we're not quite there, but you can see a little tinge of red because these are semi-transparent pixels that it's mixing red into to a varying degree based on the transparency of the pixel itself, okay? So you can see that the shader is kind of working already, but obviously we're not doing the parts outside of the shape, okay? And that's because we need to now take into account the alpha mask or the outline mask a little bit more. So let's go ahead and say color.a, okay, the alpha, right? Because let me actually say one more thing about this. This is coloring every pixel. So even these pixels out here are going to be colored red. In fact, let me just comment this out and I'll show you what I mean. If we add the A to these, then you can see anything that's transparent is getting colored with that red. Okay, but obviously we don't want to color everything because we need that alpha value to be dependent on our outline mask. Okay, so that's why we're going to do that separately down here on another line. So we're going to take our color alpha, and what we'll do is we're going to use this little max function, and it'll just take 2 colors and it's going to find the max value, and we'll start with the actual alpha value of that pixel, right? Which right now is 0. And then we're going to use our outline mask that we've calculated. Because remember, this outline mask is essentially going to be an expanded version of this. So it's going to go out however many pixels we've determined. And it's going to give us basically a new alpha value for that pixel. Okay, so we're just going to go ahead and use our outline mask here, like so. And voila, now we've got an outline. Okay, and so if we change this outline thickness, you can see that it grows and shrinks. And one really nice thing is this is a fairly low resolution texture, but you can see that our outline is getting semi-transparent pixels, okay? It's not super harsh. And we can adjust, this alpha threshold. So when we look at this, the lower we go, the more transparent it has to be before we try and color it. So like, look at this little white pixel. That looks kind of gross on this one. As we drag up, that gets covered up. If we go to 0.9, then it has to be, as soon as it's got a tiny bit of transparency, right, then it'll just start coloring it like that. And so this slider can be used maybe per texture, or maybe you just have a value that you think you prefer and you could just set that as the default, whatever the case may be, right? For this particular image, I do like dragging it up pretty high like that. Okay, but you can see what it's doing is it is blending the colors beneath. We still have a little bit of the highlight on that edge, right, coming through the red. It's not completely overriding it with the red. And so there's the version of that outline shader that allows for a more HD look that'll work good with sprites that aren't pixel art sprites. And we've created 2 versions of this shader. And when I go ahead and run this little project, now you can see even with the animation on that, it's working just fine, right? So the shaders apply to the texture no matter what the state of the texture are, and they can be changed during runtime if you want. You can manipulate those properties, or they could be set just as a generic thing across the board. So hopefully this helps you figure out a little bit about how to do some shaders. Worst case, now you've got some simple shader code that you can apply to some of your sprites and use that to add effects to your game. And if you found this useful, then please go ahead and give me a thumbs up on this video, comment below, or subscribe to my channel if you want to see the other stuff I'm doing. I want to also throw a shout out to my Patreon supporters who help make this channel possible. And as always, we'll see you next time.